Problem F19-4, gears A and B of mass 10 and 50 kilograms have radius gyration about their centers of 80 and 150. If gear A is subjected to couple moment m of 10, determine the angular velocity of gear B 5 seconds. Starts from rest. So let's look at this first gear. So it's going to have a moment going that way, and then it's going to have a force from gear B to gear A at that point. So if we do the sum of the integrals of m of gear A dt equals IA omega A. IA equals 10.08 squared, which is 0.064. So the moment's going to be caused by 10, and that's in the counterclockwise or the clockwise direction, so it's negative 10 times time t. Now there's also a moment caused by that one, and that's going to be causing rotation in the opposite direction, so it's plus the force, which we don't know what it is, times the radius, 0.1, times time, which is 5 again. And that's going to be equal to 0.6064 omega A. Now the rotation is the same direction as that moment, so this omega will be in that same direction. So this is also going to be negative. So solving this, we have 0.5 F minus 50 equals negative 0.064 omega A. Now looking at gear B, it's going to have a force down right there. It's pushing up on there, this gear is pushing down on that one, so it's going to cause rotation that way. So that same force times the radius of the bigger of B times time again will now be equal to the I of B times the omega of B. So out here let's solve IB is equal to 50 times 0.15 squared. So that's equal to 1.125. So we have the force, the radius, the time equals I so the force is, this is 1.125 omega B. So now we have force, omega B, and omega A. But because the ratio of the diameters is 1 to 2, we can say that the omega A will be 2 times omega B because it's half the radius and thus half the circumference. So putting this into there and this into there, we get 0.5 times 1.125 omega B minus 50 equals negative 0.0642 omega B, and that gives us omega B equals 72.4 radians per second.